Let's keep going. So let's do some examples with this. Just making sure everything's working. All right. So here's two examples involving just the counting principle. So here we don't actually have to list all the possible outcomes. We're just going to count how many there are. So let's say for the next semester you're registering for classes, right? Let's say you have to take a math class, an English class, a history class, and a science class, let's say. For the math class, let's say there are 5 choices. For the English class, there are 8. For history, there are 3. For science, there are 4. And again, you have to take a class from each one. Well, how many different possible schedules can you make? Well, again, a schedule would be a math class, an English class, a history class, and a science class, right? So then you would have one from this category, one from this category, one from here, which would be, by the counting principle, 5 times 8 times 3 times 4, which is 480 different schedules you can make. Again, it's just the counting principle. That's good, because I would not want to list 480 possible outcomes. So that's one example. Here's another one. Excuse me. So let's say in your English class that you're taking, it turns out you have to read a novel and a volume of poetry in that class. Well, if there are 5 novels you can choose from and 11 volumes of poetry you can choose from, how many ways can you select a novel and a volume of poetry? So the novel in this case would be the first category. The volume of poetry would be the second. You would have 5 times 11, which is 55 ways. Again, it's just multiplication. That's all it boils down to. Okay. So that's another example. Do you have any questions on this? Okay. Here's another example. Let's suppose you decide to set up a new 5-digit password for something, for, I don't know, a website account you have or whatever. And you can only use each of these digits. When they say digit, you can only use one of these digits, 1, 2, 3, 4, or 5. And it's a 5-digit password. So we're going to find out how many possible passwords you can make if repetition's allowed, and how many possible passwords you can make if repetition is not allowed. Okay. Well, for the first one, how many passwords you can make if we allow repetition? Well, basically you're choosing, right? In a sense, you could think of this as 5 categories, right? Where for each category would be a digit that you choose, right? So you can have a digit here, any of the digits here in this space, any here, and any here. It's 5 spaces here. But you allow repetition, right? So you have 5 choices for each one of these. So how many possible passwords can you make? Well, again, it's just the counting principle. I guess in a sense, you could think of each digit that you're choosing, or each space here would be a category. And each category has 5 choices. So you would have 5 times 5 times 5 times 5 times 5 down here, which is 5 to the 5th, which is this. This many passwords you can make. Okay. So again, it's almost like each digit you're choosing, you have 5 choices. Each digit would be, I guess, a category. And you have 5 digits to choose from. Okay, now this is if we're allowing repetition. What if we don't allow repetition? Well, then you could see what's going to happen here. Namely, you have 5 choices for the first digit, right? Any 5 you want, in fact. For the next one here, right? For this one, that is, You only have 4 choices because, again, there's no repetition allowed. You know, you have 5 choices here, but whatever digit you use, you can't use again. So we have 4 choices here. Then we have 3 choices, right? 2 of them have been used already, and so on. So we have 5 times 4, 3 times 2 times 1, which are 120 possible choices. So each, how do I say this? Each space, maybe, I guess, in the password, the first choice here, that is, for your digit, that would be a category. You have 5 possibilities here. You have 4 possibilities here, you know, for this category, right? The third digit in your password would be the third category. The second digit, the fourth would be your fourth category, and so on. And again, it's really just a counting principle. Essentially, you could think of like each digit here you're making in your password, each space here you're using for your password would be a category. You have 5 choices for the first digit, so 5 choices for the first category, 4 for the second category, 3 for the third, and so on. So we have 120 possible passwords. Okay. Now, this product here is actually a special kind of product. It's what we call a factorial, and it's actually very useful, so we're going to define it. So we're going to let n now be a positive integer. Then by definition, n factorial, which is denoted by n and an exclamation point, as you can see, this is defined to be n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. In other words, you're taking all the positive integers less than or equal to n, and you're multiplying them. That's all you're doing. All the positive integers less than or equal to n, and you're multiplying them together. So 1, if n is 1, well, the only thing here that's going to be is 1. The only positive integer less than or equal to 1 is 1 itself. So 1 factorial is just 1. 2 factorial, right? That's 2 times 1, which is 2. 3 factorial, it's 3 times 2 times 1, which is 6. Right? You're taking all the positive integers, you know, from 1 to up to including n, and you're multiplying them. For 4, you have 4 times 3 times 2 times 1, which is 24. Okay. And also, this is really more for convenience, but 0 factorial, this is by definition 1. Again, it's just a definition. And what's nice about that is, for n factorial, you could think of it as n times n minus 1 factorial. It's what they call a recursive definition. In particular, if n was 1, right, you would have 1 times 0 factorial, and 0 factorial is 1, so you would still get this. All right. Okay. Are there any questions about this? Yeah?
Can you hear me?
Yeah.
So this is used, like the factorial is used when we're working with trees and like just finding out how many possible outcomes there is.
It does come up there, but it can really come up in lots of places. So I'm just really defining what this is.
Oh yeah, I just was.
But factorial comes up in lots of areas. What?
I just was double checking. Thank you.
Oh, you're welcome. That's okay. Yeah.
So if we're doing a table again, does 1 always have to be included in the equation?
Say that again.
Like, does 1 always have to be included in the equation? Like for the third one, you could have just left it at 3 times 2, it would be 6. Like, why is
I mean,
one
you really should include 1 in there.
always?
Yeah.
Oh, okay. Why?
Okay.
It's just
That's just how it's defined. So
oh,
I understand what you're saying, though. So, I mean, it's probably a good idea to put 1 in there because you're multiplying all the positive integers less than or equal to n. So, including 1.
okay. Thank you.
Okay. You're welcome. Good question.